Okay, so this is an example based on something we did in class, so hopefully it's familiar. We have an egg with a mass of 60 grams, and I'm going to drop it from 2 meters. We want to know how much work did gravity do. So I underlined these 2 words because they are going to give us some clues in what direction we should be thinking about. You might also know, if you've been watching the videos and looking at the title up here, we're talking about work. So I'm going to go ahead and write my favorite work equation, which is work equals force times delta x. The other clue here is this gravity, where it's kind of in italics, and I will usually do that for you guys when I'm trying to give you a hint. So we could even be a little bit more specific and say this isn't just any old force, this is gravity. And we know a special equation for the force of gravity. So look back in your notes and see if you can find Fg equals something. Okay, Fg equals mass times this number g. Hopefully, somewhere near this equation, you also wrote down what g equals. So see if you can find that in your notes. Hopefully you found that g equals negative 9.8, and since that is an acceleration from gravity, that's going to be meters per second squared. Acceleration will always be something like meters per second squared. Okay, so we know our mass, we know g, so we are good over here. Now the question is, what about delta x? And remember that anytime you have a delta, it's always going to be final minus initial. So in this case, we might think about x2, where did the egg end up, minus x1, where did the egg start? So based on kind of some common sense and the information up here, what are our x2 and x1 going to be? Okay, so x2 is where we ended up. If I'm dropping it, we can pretty much assume that it lands on the floor. So we're going to call that 0 meters. Minus where it started out, which it says right here is 2 meters. So we've got meters for both of these. So if we kind of do the little simple math there, 0 minus 2, we're going to find that delta x equals negative 2 meters. So now we've got our delta x. We know our force, we can find our force at least. We know our delta x. It's time to plug it all in and solve for w. So what I want you to do is on your calculator or on your paper, or maybe even both, I want you to figure out what is the value for w. All right, I'm going to try finding it here with my calculator. And so what I want to do is I want to start by figuring out what is my force. Well, I said that my force was m times g, and m, we found right here, was 60 grams. So I'll say 60 grams times g was negative 9.8. And that's meters per second squared. I apologize, this is sloppy. This is what happens when you try to write with a mouse. Then we're going to multiply that by delta x. And we said delta x was negative 2. So again, let's try plugging that into our calculator. And I'm going to get 60 times 9.8, but it's negative 9.8. Times 2, except it's negative 2. I click equals, and I'm getting, it actually ended up being positive because my 2 negative signs canceled each other out, and I get 1,176 equals our W. And now my next question is, well, what unit should we be looking at here for work? Anytime we have a unit, what we're going to do is we're going to just combine the units that we have. So we have grams times meters divided by second squared, but then we have this other meter over here. So what we actually end up having is grams times meters squared, because meters times meters, divided by seconds squared. So hopefully that made sense to you. If it didn't, then feel free to rewatch any or all of this. And if you think it like mostly made sense, but you're not 100% sure, that's okay, because we're going to do a lot more practice.